SmartCAM version 17.5 introduces a number of new Toolpath modeling improvements that deliver greater toolpath control than ever before. In this video, we explore three of them: Profile Extend, Corner Roll, and Optimized Layer Geometry. First is the new Profile Extend feature. Profile geometry can now be extended or shortened by entering positive or negative length values and arc angle changes for radial profile start or end geometry. In this example, we have previously generated toolpath profiles on a portion of the wall of this solid model. Profile Extend works on the active group of elements, so we will select these profiles, ensuring that they're all identically modified in one step. Profile Extend can be used to modify the start, end, or both ends of the profile. In this case, we will modify both. We will extend the start of these profiles by entering a positive amount in arc start distance. We'll extend them by 10 millimeters. And we'll shorten their end by entering a negative 5 millimeter value for arc end distance. Hit Go, and all active profiles are then modified using our new settings. Here we have used Profile Extend on 2D Toolpath, but it can also be used to modify 3D Toolpath elements. CAM programmers may also want to extend a profile to a different boundary, such as a stock profile. First, we'll switch to a top view of the part. We saved the view and mask attributes when we last saved the solid model. We'll turn on a layer containing a previously defined boundary, and then undo our previous modification. This time, we will extend the toolpath profiles to the boundary, using the ToProfile extend method, and select any element in our stock profile to select it as the To target. Hit Go, and our profiles are extended as we required. This new feature is yet another powerful function in the SmartCAM Toolpath Modeling Toolkit. Next, let's quickly look at the enhancements made to wall offsetting in version 17.5, in particular for controlling corner roll. We built this simple example to best show the details of this feature. Previously, suppressing corner roll control was only available for line-to-line intersections. All other intersection types were always rounded. We'll take a look at offsetting control on both these sets of profiles. First, we'll use a corner roll offset on a previously saved named group of elements, Roll, adding the offset to layer 2. Choose the wall offset function, we set an offset distance of 0.125 inches, and offset to the left. We can see version 17.5 now corner rolls all intersection types. Additionally, SmartCAM V17.5 can be used to inhibit corner roll offsetting for elements that are smaller than the offset value. Previously, these elements were always corner rolled. Let's show this corner roll control using the lower set of geometry. We select a saved active group of elements that we've called Sharp. Add our offset geometry to layer 3. By choosing an appropriate corner roll angle, 45 degrees in this example, and unchecking Roll Short Segments, the user can now force non-corner rolled offsetting. When we hit Group Wall, we can see that the offsets that were previously always rounded can now be created with user-controlled sharp corners. Corner roll control is a detailed but important feature in precision toolpath modeling. With version 17.5, SmartCAM's corner roll control behavior has been made consistent on all appropriate offsetting functions. Wall offset, milling, turning, and fabrication profile processes, and with ShowPath, CNC code generation. All benefit from this enhanced functionality. Finally, we will see how SmartCAM version 17.5 can now be used to optimize layer CAD geometry in the same way step Toolpath geometry can be optimized. One benefit of being able to optimize layer geometry is in reorganizing the sequence of elements in the data structure. In this model file, we can see in the list view that the elements for different layers are all interspersed with each other, likely a result of the CAD drawing import. By selecting all elements and then using Geometry Edit Optimize, we can now quickly and easily rearrange the entire sequence of layer geometry. You can see that the elements are now in a more logical order in the data structure. The optimized sequence can be based upon layer order or upon next closest by using the Sort by Tools and Layers checkbox. Optimizing layer geometry is also beneficial when preparing for toolpath generation. This process model includes a set of hole geometry items that have been generated from the solid model. When we apply toolpath to the holes, they will be machined in a random order, influenced by the structure of the original CAD model. We will quickly convert the geometry holes to spot drill toolpath and show the resultant toolpath. Select the holes and modify them so that they are associated with the toolpath step for spot drilling. Step 10, a spot drill. Spot to a 3 mm diameter. ShowPath tool motion visualization shows that the toolpath is in the order of the original geometry in a random and inefficient sequence. We'll quickly run the process again, but this time we will use Layer Optimize before generating the spot drilling. Add all the hole geometry to the active group. Layer Optimize, starting top left and using closest. We can immediately see the improved path through the hole points. Now convert to Spot Drill Toolpath. And ShowPath confirms the now optimized toolpath. Optimizing layer geometry as well as toolpath geometry, further enhancing the flexibility of toolpath modeling in SmartCAM. SmartCAM V17.5 further enhances the ability to control your toolpath as well as your CAD geometry, making your programming processes and toolpath more efficient, saving both time and money. For more information on SmartCAM V17.5, please contact us at sales@smartcamcnc.com.